We have to admit CO2 did look guilty. Carbon dioxide is one of the greenhouse gases, along with water vapor, methane, nitrous oxide, and ozone. These gases absorb and radiate infrared radiation, which causes heat to be retained longer in the atmosphere before being emitted back out into space. That CO2 is a greenhouse gas is not controversial. As Professor Spencer Wirt explains in his book, The Discovery of Global Warming, the physical properties of CO2 were known for a long time. Back in 1850, the Irish scientist John Tyndall was the first to suggest that greenhouse gases cause the Earth to warm. In the late 1800s, Swedish scientist Svante Arrhenius also theorized that increases in atmospheric CO2 would cause global temperatures to increase, and he even attempted to work out the calculations for the expected increase in temperature given a doubling of CO2 in the atmosphere. Scientists started to study this phenomenon systematically in the 20th century. In the 1930s, Guy Callender, a British scientist, argued that CO2 was already increasing and that this must be causing the Earth's temperature to go up. Early in the 1950s, the scientist Gilbert Plass showed that CO2 has positive effects on temperature independent of water vapor, the more abundant greenhouse gas. In 1957, Roger Revelle, who later would become Al Gore's professor at Harvard, and Hans Suess wrote a famous article for the journal Tellus in which they said humans were performing a great geophysical experiment. The experiment was this: tremendous amounts of stored carbon, which had accumulated over hundreds of millions of years, were being released over mere decades into the atmosphere through the burning of fossil fuels. The impact of this sudden release of CO2, which began with the Industrial Revolution, was potentially a grave issue to these scientists. In 1956, scientist Charles Keeling began measuring atmospheric CO2 from an observatory at Mauna Loa, Hawaii, and he showed that CO2 levels were steadily increasing. Other research seemed to show that this steep increase in CO2 was primarily due to the burning of fossil fuels. Despite a global cooling scare in the 1970s, concerns about CO2 persisted. Then, in the 80s, the planet started to warm up, and governments started to respond to the scientists' warnings. In 1988, James Hansen, who later became head of NASA's Goddard Institute of Space Studies, gave dramatic testimony about the dangers of global warming. Also in 1988, the UN's International Panel on Climate Change was formed. The formation of the IPCC, for us, marks the beginning of the trial, and the 5 reports issued by the IPCC over the course of the ensuing 25 years constitutes the official record of its deliberations. The IPCC's first report was published in 1990. Its conclusions were appropriately cautious. However, the subsequent reports, coming in 1995, 2001, 2007, and 2013, contain conclusions which are increasing in their confidence and certainty. The 5th and most recent report, published in December of 2013, is said to be the most definitive judgment yet on the subject of global warming. The scientific basis for global warming is set forth in the Working Group 1 report and summarized in the summary for policymakers. The highlights of this summary are presented in a promotional video produced for the IPCC.
The scientific evidence is stronger than ever. Better and more observations. improved understanding of the climate system response. Further development of climate models, all point in the same direction. Human influence on the climate system is clear.
The summary for policymakers concludes that many of the observed changes are unprecedented over decades to millennia.
Many of these observed changes are unusual or unprecedented on timescales of decades to millennia. Ice cores contain an abundance of information about climate. Paleoclimate records show a close link between CO2 concentration and temperature. These trends are seen in current observations. Each of the last 3 decades has been warmer than all preceding decades since 1850, and the first decade of the 21st century has been the warmest.
Significantly, just as the warming of the atmosphere is unprecedented, so too is the increase in atmospheric CO2.
We're able to demonstrate that the CO2 concentration in the atmosphere has increased by 40% since pre-industrial times, mostly as a result of human activities, and that the levels of carbon dioxide in the atmosphere are higher than they've been for the last 800,000 years in Earth history.
Consistent with this unprecedented warming, the IPCC finds that the cryosphere is melting.
The effects of global warming are most evident in some of the coldest places on the planet. Ice sheets and glaciers worldwide are losing mass, permafrost is thawing, and the snow and sea ice cover in the Arctic is decreasing.
We are getting a lot of signals from the cryosphere in terms of warming. The most visible signs of warming can be found in the Arctic.
Arctic sea ice extension has shown a downward trend since 1980. A downward trend is also observed at the Greenland ice sheet.
These changes in the cryosphere are linked to changes in the ocean.
The observed changes in the cryosphere have serious implications. With less snow and ice, more of the sun's energy is absorbed by the ocean and land surface. This is one of the powerful climate change feedbacks that influences the whole climate system. Based on multiple lines of independent evidence, it's now virtually certain that the ocean is warming.
The warming of the ocean will continue even if we stop the atmospheric CO2 concentrations to increase, because the time scale of the ocean circulation, which connects the surface to the deep ocean, is very large in the sort of hundreds and thousands of years.
There are 4 major contributors to sea level rise: ocean heat uptake, melting of glaciers, reduction of ice sheets, and changes in water storage on land. Improved scientific understanding has made scientists able to make a consistent sea level rise budget.
Over the 20th century as a whole, the dominant contributions are ocean thermal expansion and the contribution from the loss of mass from glaciers. Sea level has risen by about 19 centimetres by 1900 to 2010, and it's continuing to rise. We will have to adapt to sea level rise.
With the use of powerful computer models, the IPCC claims it can make projections of future climate.
Climate models play an absolutely crucial role in this assessment report. They are the only tools that allow us to say something quantitative about the future. Historically, Climate prediction has started with predicting weather, the atmosphere, then we included the ocean, and now we're at the point where we include every component in the Earth system, including the carbon cycle and the chemistry. So that allows us to have a really comprehensive view of all the relevant processes for future climate change.
Climate change projections require information about future emissions or concentrations of greenhouse gases, aerosols, and other anthropogenic drivers. A new set of scenarios was used to project the cumulative CO2 emissions in the future.
Model simulations employing the RCP scenarios tell us we have a choice. We have a choice to live in a world in which climate change is limited to less than 2 degrees Celsius, or in a world that is warmer than 4 degrees Celsius.
All of which leads to these conclusions.
We have 3 key messages. A warming in the climate system is unequivocal. That is based on the observations and the multiple lines of independent evidence. The second message is human influence on the climate system is clear. This is resulting from the combination of model simulations with the observed climate change. The third message is that continued greenhouse gas emissions cause further climate change and constitute a multi-century commitment in the future. Therefore, we conclude limiting climate change requires substantial and sustained reductions in greenhouse gas emissions.
So the verdict is guilty, and the recommended sentence is substantial and sustained reduction in greenhouse gas emissions. The verdict rests on these findings. First, the climate system is warming, and this is based on the observed change in global temperature. It is also based on a variety of real-world phenomena which are changing in a manner which is consistent with that warming. In addition to the atmosphere, the ocean has also warmed. Snow and ice have diminished, and sea levels have risen. Many of these observed changes are unprecedented over decades to millennia, and at the same time, concentrations of greenhouse gases, principally CO2, have increased. The rise in CO2 is unprecedented in 800,000 years. The increase in the atmospheric concentration of CO2 since 1950 is largely man-made. The human contribution to atmospheric CO2 is the dominant cause of the observed warming. We know this because, first of all, CO2 is a greenhouse gas. Also, ice core and other studies show a close correlation between CO2 levels and temperature. When CO2 goes up, so does temperature. The dramatic rise in CO2 in the 20th century is coincident with the dramatic and unprecedented warming in the second half of that century. Computer models show that the dramatic warming in the late 20th century cannot be explained without CO2. Computer models show that continued emissions of greenhouse gases will cause further warming and changes in all components of the climate system. And this warming and the resulting climate change will be dangerous. Therefore, limiting climate change will require substantial and sustained reductions of greenhouse gas emissions. Journalist Donna Laframboise reports that the IPCC is portrayed as a paragon of scientific truth and authority. Its prestige is undeniable. The organization was awarded a Nobel Peace Prize in 2007, along with Al Gore. Journalists routinely use words such as gold standard, authoritative, and preeminent to describe it. President Obama's science advisor, John Holdren, said that the IPCC is the source of the most important conclusions about climate change, and that these conclusions rest on an immense edifice of painstaking studies published in the world's leading peer-reviewed scientific journals. They have been vetted and documented in excruciating detail by the largest, longest, costliest, most international, most interdisciplinary, and most thorough formal review of a scientific topic ever conducted. So that is the case against CO2, based on the latest science, compelling and uniquely authoritative. What possible defense could there be?